shut off earlier, but we're back. Okay, so we left off. Prep is basically just going through a history of how businesses use software or build the technology infrastructure for themselves. Apparently in the olden days, probably 1970s, 1980s, mainframes were all the craze. You had these big bureaucracies in business. And then that slowly changed so that people had PCs, desktops that they could use to then access any type of data they want. And you can see these different types of teams: sales, product, operations, finance, marketing. But then he talks about the semi-new way, which is the age of the cloud, which is basically just moving apps to public clouds instead of their private infrastructure. And he notes that this kind of allows for a lot of startup companies to flourish instead of big five software providers. Assuming he probably refers to companies like Oracle, Cisco, probably Salesforce. Although I think Salesforce might have been part of this new wave of enterprise software companies, but this allowed them to scale. So you think of Snowflake, that company. It's like the only one that comes to mind right now. Confluent as well. All of these all rely on public cloud infrastructure in order to build their apps. And I'm sure things like Airbnb, Uber as well, they're non-enterprise software companies, also have been able to do that as well. I guess Workday, Monday.com, those are all examples that he provided. So he also mentioned, I think this is a pretty interesting observation, that all SaaS pricing models was done on a per-seat basis. So number of users that log in / use the software. I think if that number increases, then the value or the pricing of the software itself increases as well. So you kind of scale linearly. And let's see, pricing tends to scale linearly with the number of users.
Software, that's how valuable it is. And if you think about what you see a lot in modern systems, you still have some per seat stuff, but you have a lot that is sold by consumption or by utilization or what it's actually carrying out in the back of the business, regardless of how many people log into it. So, this really allowed us to get to scale in terms of these software investments, and it's a good thing, right? Well, kind of. The result was we had all these valuable software investments. We got a lot of these things, and the result is a big of a mess. If you were actually starting on a whiteboard and trying to think, how would we lay out this company? How would we actually design the software backbone for this organization? I think in a lot of cases, this is not what you would have ended up with. You wouldn't have ended up with this kind of big ad hoc set of things that were interconnected. It's just that we got there bit by bit. We kind of boiled the frog a little bit at a time. And the result is often slow. It's often error prone. It's kind of difficult to work in. And this has been the situation that we're in, and this is what gave birth to the rise of data streaming. It was really aimed at trying to fix this, trying to go from a world where data was about storage. It was about all these little islands of data having their own little pile of bytes that are just theirs, that are there to kind of look up and guard, and move to something where data flows in real time across the organization. All the parts can connect to each other. And this has been incredibly successful. For a lot of the people in this room, this is a technology that's at large scale in their organizations. It's driving really important parts of the business. But while we were working on that, something else happened. And I think it's no secret we're entering the age of AI and important parts of the business. Technology that's at large scale. It was about game prone.
Gonna take this. Yeah, I don't really know exactly how this works, but let's see.
It's kind of difficult to work in. And this has been the situation that we're in, and this is what gave birth to the rise of data streaming. It was really aimed at trying to fix this, trying to go from a world where data was about storage. It was about all these little islands of data having their own little pile of bytes that are just theirs, that are there to kind of look up and guard, and move to something where data flows in real time across the organization. All the parts can connect to each other. And this has been incredibly successful. For a lot of the people in this room, this is a technology that's at large scale in their organizations. It's driving really important parts of the business. But But while we were working on that, something else happened. And I think it's no secret we're entering the age of AI. And it's not your grandparents' AI. It's not even the AI I studied when I was in school. A lot of the same techniques. But if you think about the power of these systems, there's really different implications. And I think that this is going to dominate a lot of our thinking about software development. I think it's going to have really big impacts on data infrastructure, data architecture. I think it's going to supercharge this process of companies becoming software, of how all these parts connect and what you can actually do in software systems. And the reason for that is kind of, again, the same thing. As economics tells us, when something valuable gets cheaper, you get more of it. And it turns out that modeling a business in software is actually pretty expensive. Cloud made it a lot easier to run software systems. But in a sense, it didn't make it easier to write software systems. And AI actually changes that, not in the trivial way of just it'll generate a lot of code for us, although it does do that. In actually a deeper way, where it makes the process of trying to model a business in software easier. There's always been a set of things that are really hard to translate into hard-coded rules. It's like you could tell the intern, oh, go do it this way. But telling the computer to do that has always been really difficult. There was no function you could call in Python that was like, use your brain, right? That didn't exist. Only now it kind of does, or it's starting to. And what this means is we can go after a lot of problems that we couldn't before. A lot more can be done in the software layer than used to be in a business. And I think the key lessons are the same. It's not the case that the new thing replaces the old. The old hard-coded applications that we've written, it's not like they're going extinct. That still has a really valuable place. But it's increasingly going to be complemented with intelligent systems that drive a lot of action. And so this is actually a really fantastic position to be in, I think, for everybody in the room. There's exciting things happening. We get a new technology transformation. But there is one problem, which is ultimately this hasn't really gone away. We're actually not quite ready. We got to ask ourselves, is this really the right foundation for building AI-driven applications? Are we in a state where we can really tap into all this data and make use of it? And I think in a word, the answer is no, right? The big mess is still, in large part, a big mess. And so what is it that we need to do to make these AI efforts successful? What is it that we need? Well, a system like ChatGPT or
Look at Cloudflare real quick, because I think Cloudflare was really trying to be the software infra for the internet. Yeah, there's somewhat of a... Okay, never mind. I don't know what... Content delivery. How is that? So software companies providing internet infrastructure. 2000. I guess Cisco is probably one of them. Oracle. Sun Microsystems. Okay.
Or Claude, they're trained on static data from the internet, and that makes them kind of like a well-informed friend who reads a lot of Wikipedia. That friend is actually pretty useful, but you can't really drop them into the middle of a business and have them take on some important job and suddenly start carrying it out. They actually don't have that capability because they don't know anything about it. What they need for enterprise usage is something where you can bring your data about your company, your customers, your sales, your procedures, bring that right to bear in the operation of the business. And to make that work, it has to be the right data. It has to be the data about the actual things that are relevant to that use case, to that application. And it has to be available right now. It has to be up to date with what's happening in the organization. These are the things that we need for AI is the right data at the right time right now available to our apps. So how do we go about doing this? To explain it, I'm going to walk through a simple example. I'm going to start with something, it's a little trivial. Let's look at kind of the architecture of a chatbot that's answering questions. We'll do this for a consumer bank. I might want to answer questions about my spending patterns, the trends I'm seeing, the fees I paid, the interest I've made, the transactions that have occurred. If I want to do this, I have the problem of ultimately connecting this intelligent model that has some reasoning capabilities over on the left to this big data mess over on the right. How can I kind of get that data and make it available to the model? And how am I going to actually hook these two things up? Now, some of the questions that the user might ask, they might be kind of simple FAQ stuff. So maybe it's the same every time. What time is the bank open? Mostly the same, maybe a little different on holidays, maybe it varies on where you are, but it's not that complicated. But a lot of the questions that people are going to ask are going to be very specific to them. It's going to be about their transactions. It's going to be about what they just did. And we have to get the right answer for those questions. And so ultimately, how are we going to build this kind of thing? And a lot of people, when they think about this, they assume the answer is going to be kind of like how you built Claude or ChatGPT in the first place. We're going to somehow get all the enterprise data, and then we're going to train a model on that data, and then it will know that stuff. And it's intuitive that you would think that way, but it's actually not correct. And there's three reasons that this isn't quite right? One is we could do that, but trying to counterweight all the facts on the internet with our small pile of enterprise data, the reality is it's not going to be a very reliable representation. We're going to have a lot of hallucinations. And that's not the only.
Okay, so data streaming for AI. Call this 11 minutes in. Building AI pipeline. Training on enterprise data is feasible, too complex, and says it's prone to hallucinations because wait, I guess he's referring to it's overfit on the enterprise data. That's my guess. So he's basically saying that it's going to overfit on the small sample size.
Only problem. The other problem is these training processes are big batch operations. Think weeks or months, right? And I don't know about you, but if I'm checking my account balance, I don't want to know what it was a month ago. I want to know what it was right now. The questions I ask, I want to know what's happening as it happens. And then maybe the most important problem is there's not in these models any sense of access control. There's no, this data is for you, and this data is for me, and this data is for somebody else. It's all just kind of in there. And so it can never be the case that I ask about my account, and suddenly I'm seeing your transactions. That's the kind of thing where the executives have to go before Congress and explain what happened, right? That's a really big problem. And so for these three reasons, it's not about training everything on your enterprise data. I mean, there's obviously some training involved, but that's actually not the problem that we need to solve. It's how do we harness this and combine stored data with the model at runtime? And this should not be super surprising. If you think about how does a human teller work, right, in a bank, we don't make them memorize all the transactions of all the customers. We train them on basic procedures for how to interact with people, but they look up the information they need about you when they help you. It's not that complicated. So this architecture has a name. It's called retrieval augmented generation, and this is becoming increasingly popular. In these areas. And the idea is I'm going to gather all the data I need from different systems. I'm going to represent that in the way I need it. Could be in a traditional database, could be in a vector database, could be in a traditional database with vector database capabilities. I'm going to put it someplace I can look it up, right? And this data could be all kinds of things. It could be information about our customer. Maybe we're gathering bits of data about the customer, kind of joining it together, getting it into some representation that has the right context for who you're answering questions for. It could be about their transactions. It could be similar examples of good questions that have been answered in the past. And that kind of inexact matching, that's where a vector database comes in, where you can kind of match something that sort of sounds like or is related to. And so I need some kind of indexing pipeline that's going to build this representation. And then I'm going to augment the query that the customer has. I'm going to take the question that they have, and I'm going to add this context information and ask a richer question to the underlying model that has everything they need to know about that person, about what they've done, about the side information to answer the question that's being asked. And that's what's being sent out to this language model. So how can you build something like this for a production app? As we're thinking about really taking these AI systems from kind of demos that mostly work to something that really runs reliably, well, there's a huge role for data streaming in this. And you can see that very much in that indexing pipeline. How am I going to connect into all these systems, get the right bits of data, get it into the right representation? In the vector database case, how am I going to compute the right embedding so that I can store that in a way that I can do my inexact matching? This is a great use case for something like Flink. And one of the things we've been working on at Confluent is adding this kind of direct language model capability into this, so you can apply these directly on the stream. And we'll be talking more about that in this keynote. So this is an easy start. We said we start talking about chatbots, and I said I would answer the question, what does AI need? It needs data. It needs the right data right now. And I think what it actually needs is a data streaming platform. It needs infrastructure that can work with this kind of real-time data at scale across the organization so you can get the right things, and you can get them in a way that's continuously up to date and maintainable. And with that puts us in a position to start to move to something a little more advanced. If that RAG example was kind of a simple chatbot, and maybe we have more chatbots in our life right now than we absolutely need, that isn't where this stops. That's an exciting place to start, but if that was all we could do with AI systems, we wouldn't be as excited as we are. What's really exciting here is the ability to have agents, software systems that go do some of the work in the background that kind of help pitch in. That's ultimately what we want. And I think what you need for this is not entirely different from the chatbot example, but it can actually take over some of the work. So in that chatbot, maybe I could ask questions about my account, how are things trending, what's my spending. But something like an agent, I'd like to be able to give it some tasks to just go and do. So I have 2 teenage daughters, so maybe I could ask it, hey, I'd love you to keep tabs on their account, and if there's any spending that a parent should be concerned about, maybe let me know. Like, I don't want to invade their privacy, but if there's anything really bad going on, just let me know, maybe pause transaction processing for a little bit. That would be useful to me. That's more like an agent where there's some activity that's happening in the background that's kind of running continuously and looking at what they're doing, and I don't have to worry about it day to day. I don't have to log into the app and check every day to see what's going on. So, what is it that we need to enable this? Well, in part, we need better models. To actually trust something to work in the background autonomously, it has to be pretty accurate. It's like, you're not going to turn the intern loose with full root access on the system. You wait till they have a certain amount of capabilities. And the reality is we're actually getting there. We're progressing on model quality. You would see this in the announcements from the different companies working in this space. These things are actually getting better. And you don't see an immediate plateau happening anytime soon. And the other thing that you need is you need reliable data. The same issues that can be caused by hallucinations or poor judgment can be caused by wrong input. You tell even the smartest person the wrong facts, they're going to get to the wrong output. And the architecture for building this kind of agent doesn't look that different from what I showed before. You still probably want to gather that same input data. You still probably want to have some kind of maintained context that you're using. You're still going to be triggered off maybe this stream of transactions that you're processing. But now your output is not just a chat. It's actually the notification event. It's the pause transaction processing event. It's context on what's happening. It's all the activities that you want the rest of the company to react to and to go carry out. And so this ability to take AI from simple chatbots to these autonomous agents, I think this is a really powerful thing. And I think Flink is an excellent platform for these kind of asynchronous agents. And the same capabilities in Flink that enable those embedding computations, enable this kind of AI applied on streams. It's very much the same thing. We'll talk more about this. So, this allows us to take something that could have been a simple demo and actually run it in a way that scales out to the large amount of data that we have. That's fault tolerant, that's reliable, that fails over, something that's a real production process. And I think that there's big implications for this when we step back and we think of what this means for what we can do in companies, right? We're moving from a world where data systems, software systems were ultimately oriented around people. It was about how do we store the right data so we can look it up and put it on a screen. Cool. And any action, no matter how mundane, it's got to be somebody sitting there pushing the button saying, yes, do it. So the infrastructure is ultimately about storage. It's like get the right stuff and be able to look it up at the right time so we can show it to them. But we're moving to a world where this is a little different. Instead of just waiting around for the humans to log in, the software systems can be working continuously. They're awake, they might as well do it, right? And so we're moving from a world of storage to something where it's like continuous stream processing. And I think this is going to be a powerful force in both driving the scope of software across organizations, the rise of data streaming in these organizations, and I think it's just a powerful thing in terms of what you can accomplish with software in companies. And I think it has profound implications. So, if this is where we're going, do we know how to do it? What is it that people are doing today as they approach this? We're just learning how to build these applications. And I think we're doing all kinds of things. You would see all kinds of experiments, people in this room doing really interesting work. You can hear about these in some of the talks. I would say one of the things you see is that a lot of the thinking is very lakehouse or data warehouse oriented around AI. And I think it's almost a little bit by analogy. People feel like, well, AI, it's kind of like analytics, and analytics happens in the lakehouse or the warehouse. So if we're building an AI app, maybe it goes there and these data scientists will do it. But I don't think that's necessarily what we're going to see. I think AI apps are going to be something that everybody builds. Like if you're a software engineer, I think it's going to be part of your job. And I don't think it's going to be limited to a team of data scientists. And if you think about the setup in a lot of these lakehouses, these are really important, valuable systems, but it's not actually ideal for these AI apps, for a couple reasons. If you think about the paradigm in this area, it's mostly about kind of scraping batches of data out of different parts of the organization, kind of cleaning it up after the fact in some ETL or ELT process, kind of making it available in some more structured, easier to use form in the lake. But this has a couple problems when you try and put it to practice in the world of AI. The first is that this kind of after the fact governance, where there's a team kind of scraping data from all the different systems around the organization, it's a bit fragile, right? It's a bit fragile even for a reporting or analytics system. It becomes really fragile if we suddenly have software agents carrying out parts of the business. If something changes upstream and all these processes downstream don't know about that, they're going to break. And you're going to have either broken data, unprocessed things, or worse, just wrong results, right? And this is a really big problem. And this paradigm of just kind of dumping data as it is and figuring it out later, it makes it ultimately pretty fragile because the people working on that cleanup, they are not necessarily in sync with the data upstream. They don't necessarily know all the intricacies, and they don't necessarily know when it changes. Now, hopefully everybody talks to each other, but as we know, as these number of dependencies get larger, the chance that something goes wrong goes up. The second problem, ultimately this batch stuff is too slow. At the end of the day, if we want to have our AI agent or chatbot or these AI applications be in sync with the business, it's not going to be enough to have kind of a batch extraction and then a series of batch processes, one after another, that kind of churns through all that data, and eventually we get something that's usable. That's going to be too slow. That's going to be out of sync. It's going to be hours or days delayed. And if we want something that's actually executing part of the business, it has to be in sync with the business. It has to know what the bot is.
Not entirely sure how Confluent is able to solve this though. Don't you always need to clean your data? I don't know what he's talking about here.
But as we know, as these number of dependencies get larger, the chance that something goes wrong goes up. The second problem, ultimately this batch stuff is too slow. At the end of the day, if we want to have our AI agent or chatbot or these AI applications be in sync with the business, it's not going to be enough to have kind of a batch extraction and then a series of batch processes, one after another, that kind of churns through all that data, and eventually we get something that's usable. That's going to be too slow. That's going to be out of sync. It's going to be hours or days delayed. And if we want something that's actually executing part of the business, it has to be in sync with the business. It has to know what the state of things is. And finally, if we think about the third problem is that we have this wonderful, simple picture where we just imagine data flowing in one direction. It all goes to one place, and that's where it is. But the reality is more complicated. The reality is there's a ton of data exchange in the operational side of the house in all those systems. There's usually more than one analytic system in a company over time. There's a number of things. And this isn't one direction. After all, the whole point of our agent was to send back a stream of actions back to production and drive operations. And so there's a ton of loops between these systems. So if we think about a one-directional flow, sure, we can put all the data in one place and have a team that cleans it up there. But there's also data being shared between all these operational systems. Are they going to have to do the same cleanup that's replicated in the lake? What if that gets out of sync? Like, it's duplicate work, but can we even get that done? And so this ability to get the high-quality data to all the places, that's a pressing problem to really enable a whole ecosystem of AI applications. And so I think what we need to do in this world is really kind of shift left our thinking. Really take some of the processing and governance to make data good and hand that over to the team that produced the data. This is the idea of data products, that each team in the company, if you own a piece of software that has data, you're going to publish out a real-time stream that's well-structured that other people can subscribe to, that they can build around.
Okay, this is an interesting way of describing things. Okay, so call this confluent vision of the software stack, right? Teams are going to align data products opposed teams that build software. Produces some type of produces some type of data teams that build software that produce some type of data. Just openly share data. Other applications can subscribe.
That has real rules for how it's a company. If you own a piece of software that has data, you're going to publish out a real-time stream that's well-structured that other people can subscribe to, that they can build around, that has real rules for how it's going to evolve. That's kind of like your API to the company for your data. And this is going to be a really important output from every system, because that data stream is what's going to power all these AI use cases. It's going to power all the analytics. And that can be the feed into the other operational systems. It can be the feed into the AI applications. It can be feed into the analytics realm. We can kind of do it once for everybody if we get that right. And those kind of governance tools can be owned upstream. so that that team, as they evolve their application, they're going to keep that contract of the data that they're sending out. And that means that you can actually build around this in a dependable way, that that data can flow in real time, and that anybody can have it, any of the different systems. So it really solves all three problems I just described. So that's where I see this going. So how do we get started on this? If you have this big mess, how do you get to the kind of well-governed streams? Well, the good news is this is about 1,000 times easier than it used to be. A lot of these capabilities are available as a service. The world of stream processing has gotten a lot richer and easier to use than it used to be. So that
No, yeah.你猜我去楼上了。
I want you to be here. Motivate me.
I'm gonna go upstairs for like an hour, and then I'll come back down. Yeah. You want to use your? Yeah. Yeah.
tools are a lot more mature. A lot of the patterns are better understood. And the really good news is you don't need to try and do this all at once. There's not some big death march project to try and get to the central nervous system where everything works around streams. It happens one application at a time. One well-formed data product at a time, one stream at a time. And if you do that, you're very much on the path to this better state. And if you talk to many of the people in this room, they're well down that path. They actually have this stuff running at very large scale. It's powering a lot of the interchange between the different software applications they have. It's there in the stack for a lot of these new AI capabilities, and is really becoming very much the central nervous system in their business. And so I think this architecture is even more important than ever. I think that the rise of AI is powering the adoption of streaming. But I do have to amend one thing I said. I said companies are becoming software. I should probably amend it and say companies are becoming software and AI. You know, there's going to be enough of this stuff and how our companies operate. This is going to be a really important part of the solution. And you know, so that's what I have to say about that. But you don't just have to take it from me. There's really interesting things happening from actual organizations out in the world. So we're going to hear from 3 companies that are putting this stuff in practice. They're building out their data streaming platforms. They're actually using it to connect across different parts of the organization. There's efforts around AI. And you know, it's really at large scale for some of the coolest products and services out there. And so I want to welcome to the stage you know, folks representing these companies who are going to tell us all about what they're doing. And with that, I turn it over. Thank you.
Please welcome Software Engineering Manager for Mercedes-Benz R&D North America, Seema Achadia. Software Engineering Manager for Mercedes-Benz R&D North America, Seema Achadia.
Okay. Glad to see some use cases here.
Thank you, Jay. Great to be here with everyone today at Current. I am Seema Acharya, Engineering Manager of Mercedes-Benz Research and Development North America, or MBRDNA for short. Mercedes-Benz is one of the first OEM that had their R&D in Silicon Valley. We have been there for over 3 decades, and we have spent our time investing our time and resources to ensure we build the most desirable cars. Let's look into some of the challenges that is faced by our automotive industry in the data realm. As a luxury brand, our customers expect a hyper-personalized experience. So let me walk you through a day with Mercedes-Benz, a hyper-personalized experience. Imagine getting into your car, and it's a hot day, like it is today, and your car already knows what is the temperature setting that you like, and what's the ambient lighting you like, and it puts on your favorite music or news, whatever you like to listen to, on the way to work. Not only that, it can predict what is the drive that you're going to take to work, because there is, let's say, some additional traffic or blockages on your regular route. And not only that, with our Level 3 drive now, it can also drive you there. So in order to, and this is just some of the examples. So in order to achieve this kind of personalization, what are some of the things that we have to do in the backend? So we can divide internally into our use cases into these 3 main pillars. If you think of a car, it has, with all its multiple ECUs, multiple data channels that come out of it, you can consider that to be a very complex IoT device. Unlike a phone, which you probably own for 2 to 3 years, a car lasts sometimes throughout generations and passed on even sometimes. And we also support it for 10 plus years. That is why data curation is one of the most complex things we do. And in order to, we have to bring data sources in and clean it up and curate it and create very well-defined data products. And this now is ready to use internally within our ML and AI teams. And last but not the least, we also need observability and insights into what is happening with our fleet, what do our customers like, and what do they not. So let's take a look into how is the world and before, and how were we kind of tackling this problem. We had multiple data platforms to handle the incoming data. We get data not only from the fleet, but from the vehicle, ECUs, and our applications, and also our backend services. And this would be then would go on and get distributed to multiple streaming platforms, and also then would go on. For example, we used open source Kafka, we used Kinesis, we used event hubs, and then later on, it would need some cleaning or enrichment or anonymization, and this would be done through, again, various different ways, like open source Flink, we use stream analytics, and so on and so forth. So this is a nightmare for developers. We have every team did not have a luxury of having data engineer, and how do we bring them kind of closer to the data? And reusability was very low. Now let's take a look into what we are currently doing. So as Jay was referring to, the data streaming platform is exactly what we ended up building. We use Confluent Cloud to power all our data streaming needs.
Oh, wow.
And especially our team is super excited for Flink. And we use like Flink and KStream for our stream processing needs. We use Confluent Cloud to power all our data streaming needs. And especially our team is super excited for Flink. And we use like Flink and KStream for our stream processing needs.
And what?
And we use like Flink and KStream.
KStream.
For our stream processing needs. Shifting left, we did not know what this term even meant. So it's great to have like a name for it. If you ask my team, they're like, probably they invented it. So what we ended up doing is bringing the people who work with the data closer to the data. We also shifted governance left to make sure that is least privilege access to the data. Now coming back to data curation part of it, which is the most complex problem that we take care of. Bringing in data from these multiple sources, we collect it into our data streaming platform, and then we distribute it out now and create like very well-defined and curated set of data products. Collect it into our data streaming platform, and then we distribute it out now. Into our data streaming platform, and then we distribute it out now and create. Bringing in data from these multiple sources, we collect it into our data streaming platform.
From multiple sources to a data streaming platform.
And then we distribute it out now and create like very well-defined and curated set of data products.
So collect data from multiple sources and then distributes it out. Data products with as well defined data products. I guess probably the schema of the data itself.
Now, once the data products are ready, the AI and ML teams now can take this on and make real-time inferences and make real-time recommendations back to our customers. And this is how we, and also combine it to our external data sources like weather data to create this very hyper-personalized experience to our individual customers. Next is observability and insights, which is key. Confluent has a great set of connectors and integration to many data analytics tools, which makes it super easy to make this happen and get an insight into our fleets. Last but not the least, governance and security is of utmost importance to us. So stream lineage, and which gives you a very comprehensive real-time view into what is happening with all our data within our platform in real time. So this is something that our auditors absolutely love. So yes, it has been a great experience so far, and cutting time for our developers and making things reusable. So what does this all mean for us? Let's start with what is the benefits for you awesome developers, because you are the ones who make it happen. Reusability is one of the keys. For developers, this data platform that we built handles around 800 terabytes of data per month.
Oh, shit.
And
Oh, wait. 800 terabytes. Right, I think if you looked at the pricing earlier, it's 5 cents per gigabyte of read and write. So 800 terabytes, that's about 800,000 gigabytes, right? 800,000 times I think that's 40,000. Oh, sorry. Yeah. Yeah, $40,000, right? It's pretty cheap, right? So 800,000 times 0.05. 40,000, right?
This data platform that we built handles around 800 terabytes of data per month and over 180 billion events per day, and it's
Billion events per day. I imagine that probably only goes up, like it never goes down.
growing year by year. And because we have built these reusable pipelines, 80% of the dev time now is saved, and they don't have to worry about maintaining this complex ecosystem, both streaming and stream processing, which has super high barrier to entry. Reusing real-time data products instead of starting from scratch. For businesses, for the business and the other organizations, what it does is gives a comprehensive view into what is happening with our customers, what is happening with the fleet, and they don't have to wait a couple of months, a lot of things lost in translation to get insights into what our customers need. And our time to market has reduced greatly. Imagine like each one of these data teams building their own pipelines. It would take somewhere around 4 to 6 months to do this from scratch every single time. Now we have reduced the time to market to somewhere at the realm of 4 to 6 weeks, which has been great. Last but not the least, security. Mercedes cars are sold all over the world, and we have to comply with different regulations, EU Data Act in Europe, GDPR, California Data Act, and just to name a few. So the shift left in governance also helps us that, and also a real-time view into our entire data ecosystem also helps with this. So all in all, seamless integration of our data and intelligence systems.
Data processing at rest. Okay. So I guess that's how. Okay, interesting. Yeah. How long are these videos? Okay, about 40 minutes. This could be one to look at in the future. Okay.
Systems allows us to transform each Mercedes car into a dynamic learning companion that grows alongside its owner, setting new standards for luxury automotive. And though this applies only for us, for the automotive industry, I hope all of you can take something away today. Thank you so much.
Please welcome Head of Technology Strategy at Confluent, Andrew Sellers, and Chief Data and AI Architect for Accenture Global IT, Adam Tybor.
Adam, it's so great to be with you here today. It's been such a pleasure to get to know you over the last year as part of Confluent's Customer Advisory Board. I'm so deeply impressed with the work that you're doing at Accenture. Just to start us out with the audience, can you please briefly introduce yourself and tell us a little bit about your role at Accenture?
Sure. Thank you for having me. I'm excited to be here. The role at Accenture, so Accenture is one of the world's leading technology service providers, and I work in the global IT space, and I lead up our data and AI strategy. And so we're responsible for supporting the business and helping grow the business, $65 billion in annual revenue, and we support about 700,000 employees across 120 countries. And so not only supporting the employees across 120 countries. And so not only supporting the business, but a big piece of what we do is also partnering and trying to innovate with the business to continue to drive growth and competitive advantage.
And that's awesome. So I know every journey's got to begin somewhere. Can you tell us a little bit about the early days of data streaming with you all and some of the initial wins that you experienced for the business?
Yeah, absolutely. So it started several years ago. We were finishing our cloud transformation, and our CEO, Julie Sweet, said a very enlightening thing. She said, cloud is the enabler, data is the driver, and AI is the differentiator.
Okay. Julie's previous Accenture CEO said, cloud is the enabler, data is the driver, and AI is the differentiator. Okay, might have to steal that.
And I think, boy, was she right? Looking at it where we are today. So while we were finishing our cloud journey, migrating the majority of our IT estate there, we really needed to focus on the data. And I think, like you've heard and seen, probably not unlike a lot of you, we had a data mess on our hands. We had a lot of point-to-point batch jobs, thousands and thousands of orchestrated batch jobs, very tightly coupled. It was very long to get anything done. And so we really needed a new paradigm shift, and that's where leveraging the power and the scale of the cloud and open platforms like Kafka, we were able to find new ways to kind of unlock our data from these platforms and get it flowing in a much more simple way.
And that's amazing. And I think through what it takes to actualize data products and to use them in an enterprise-wide way. Can you help us understand some of the challenges beyond tech, some of the process and organizational things you had to overcome to really actualize everything that you accomplished in that journey?
Yeah, absolutely. And I think one of the most important things was being able to move fast. Finding a product like Confluent Cloud, I think, really helped us move at speed. We were not focused on some of the lower level infrastructure, but we could have our data engineers and our expert developers really start focusing on solving business problems and trying to add value to the business. And so one of the really important things was, by leveraging a cloud SaaS offering like Confluent Cloud, we were able to build standards that were repeatable and reusable. And it also gave us internally a way to kind of give constraints to say, well, this is the standard, this is how you have to go consume it, which ultimately made it easier for everybody.
And that's awesome. And so now that you've got to the point where you have this enterprise-wide data streaming platform, what is some of the value to the business that you found?
Yeah, absolutely. I think it's interesting. So not only are we getting the data more real time, which is opening up a lot of new opportunities that I think before we never would have imagined, just because the data wasn't available in this format. It's also speed to market. So one of the interesting things is in the past, all of our projects used to start with data integration, and it would take weeks and months to just kind of get all the data and copies of that data off the ground. And where we have the data streams in place, those new experiments tend to go really quick. And so we can adjust and iterate and prove things out much quicker.
That's awesome. So, but beyond the business, I gotta believe that your developers must.
And past all of our projects used to start with data integration, and it would take weeks and months to just kind of get all the data and copies of that data off the ground. And where we have the data streams in place, those new experiments tend to go really quick. And so we can adjust and iterate, improve things out much quicker.
That's awesome. So, but beyond the business, I gotta believe that your developers must, see benefit as well. Can you talk us through some of what they like about having a data streaming platform?
Yeah, absolutely. I think the biggest benefit is they don't have to think about it anymore. So we're able to provide, our own internal service on top of the offering that gives them a standard way to consume that data. And one of our principles for the program was always frictionless consumption. We want to make it very, very easy for people to get access to the right data at the right time. Tomorrow afternoon, we actually do have a session where we talk about our shift left, which is our data supply chain. Yeah. If you want to know some more of the details, I think that's at 2 o'clock tomorrow afternoon.
That's awesome. I encourage everyone to check that out. That sounds really, really fun. And so, Adam, I got to say, no journey's ever done, even though you've accomplished so much. What's next?
Personally, I want to see every batch job eliminated in the organization.
Good.
Won't be satisfied till that happens.
We'd love to hear that.
But I think what's been amazing is with Gen AI happening so quickly, and with our data.
A very interesting. Tiber wants see all batch jobs eliminated.
Products. Obviously, that journey is not complete, but we have the data products and we have the data ready. We've been able to really take advantage of these new technologies. And I think it also offers this decoupling platform where as new technologies come out, again, it gives us the ability to experiment without a lot of disruption to the day-to-day work.
Adam, thanks for being here to just share with us what you've accomplished and to help others on their journey as they fully build toward a data streaming platform. This was awesome. Can we give Adam a hand, please? Thanks, Current. It's awesome, buddy.
Thank you very much.
That's great.
Please welcome Head of Data Platforms for Viacom 18, Kushal Khandelwal.
Hello. Good morning, everyone. Great to be here in Austin at Current 2024. I'm Kushal Khandelwal. I lead the data teams at JioCinema. Today, I'm going to talk about why a rock-solid data platform is critical to what we do at JioCinema for both where we are and where we are going. But before that, can we go slide back? Yeah. Just before that, I would want to start with a bit of context of what we do here at JioCinema. So JioCinema is one of the leading digital streaming OTT platform based out of India.
Oh wow, okay, so leading streaming platform. Of India.
We stream both live and VOD content on our platform that spans across entertainment, sports, kids, news, and short form.
And the platform. Their platform, so sports, kids, news, and short form. I'd actually be very curious on how the live stream situation worked with the Mike Tyson Jake Paul fight, and if Kafka or Confluent was involved in that. Let's see, quick ChatGPT. NFL games, okay. Can Netflix fix its live stream service? Service providers, okay. Yeah, interesting. ISPs to get priority bandwidth. Okay, this is very, very cool, the networking behind the scenes. Okay.
We stream over 100,000 hours of content on our platform in 19 plus languages and catering to over 600 million customers on our platform. We also stream over 35,000 hours of live content on our platform every year. We are the most downloaded app in India in 2023, and we are continuously growing. You all might have heard about cricket being one of the biggest sporting event in the country, in India.
23.
The Indian Premier League is one of the biggest cricket tournament, which we stream on our platform live. Now, to give you some context, the last edition of IPL, the 2024 edition, just recently concluded in May 2024. To give you a sense of the scale we deal with, let me just talk you through some of the stats around IPL. Last IPL, we did 26 billion views, which amounted to almost 350 billion minutes of watch time on our platform. This is 5x of the next biggest sporting tournament here in USA, and that's the kind of scale we deal with every day within our platform. Now, to build at this India scale, or the Bharat scale, what we like to call it, we needed a real reliable data streaming platform. Kafka being the de facto standard for anything data streaming, what really started for us with Kafka was to build analytics and insights system that quickly evolved into a much larger ecosystem within JioCinema. We then started to build event-driven applications, microservice architectures based on Kafka, building notification systems, communication systems, and a lot more over there based on Kafka. Now, to run things at scale, you need to manage a massive infrastructure in form of Kafka. And mind you, not that we can't scale Kafka. We have done that in the past and we've been doing it. But we really felt that's not the best use of our developer time. We wanted to have more time invested in building customer use cases and new products for our customers rather than managing infra. And that's where a bigger data streaming platform comes into play and becomes very important for us. So if you just look at a high level, what we do on our data streaming platform is it enables us to connect and stream events from all our consumption surfaces, be it mobile devices, your iOS and Android apps, or the connected television devices across all the living rooms in your households. But we also are able to stream data from a $10 smartphone, which is coming from JioPhone, it's a 2.4-inch smartphone from where we are able to get all of that data into our platform. So at a high level, we bring in two sorts of data into our ecosystem. One is your clickstream data, which kind of talks about what the user is really doing on the platform. The other is the heartbeat data. So heartbeat data helps us to understand what video you are playing and how many users are watching any content on our platform. Together with the data streaming platform, we've been able to convert our heartbeat and clickstream data into really high quality data assets, which enable us to deliver that seamless cricket watching experience or entertainment experience on our platform. With this data set, we were also able to build a much more effective targeted advertising on our platform, do better recommendations, do better personalization, and a lot more for our customers. Now, let's just quickly talk about one of the use cases on our platform and where the data streaming becomes very critical to us. You all might have heard about views being one of the currency in the video streaming world. Now, views is more or less a reflection of historical popularity of any content. But we also really care about one more different metric, which is called the concurrency. Now, concurrency is nothing but just saying that how many users are watching the content on our platform at any point of time. Now, this particular thing is very important for us to understand the scale at which the platform is operating at any point of time. You know, any live sporting event, in our case, let's say the IPL or cricket, they generally have a very spiky traffic pattern. Within a minute, there's a new marquee player on the ground, and the crowd goes crazy, and then there's a surge of new users coming onto our platform to stream the content. In our case, just taking an example, there's a player called Dhoni. When he steps on the crease within a span of a few minutes, there will be 5 million, 10 million users who log into our platform and start streaming the game. That kind of translates into a huge volume of data which we need to process in real time. Now, building at this scale is not an easy task. Sometimes it just takes a village to run services at that scale. So for our engineering teams, auto-scaling never works, right? So they needed to get a sense of what is the concurrency or how many users are watching the content at any point of time on our platform. And that's where we started building the concurrency ecosystem based on Kafka. So how it really works is that all our client application, all the consumption surfaces, they're able to emit something called as a heartbeat. Now you can imagine heartbeat by saying something that every time any user is watching a video, we emit an event every minute. It's just to say that, oh, I'm alive. This video stream is alive. Now, for the scale of streaming what we do, we stream at maybe IPL at 30 million or 50 million concurrency. This translates to close to 1 million or 2 million messages per second, depending on the frequency of the heartbeat, which we need to really consume and process in real time to get to that number. That concurrency number is very critical for us to run a stable, resilient streaming platform, because all our backend systems, all our streaming systems, any other system which is being used internally is listening to that concurrency number throughout in a real-time way, and they react to that number, react to that concurrency, are able to dynamically scale their systems to just deliver exceptional performance for our end customers. So now combine this with concurrency, we also have this video quality of service data coming in with Heartbeat. That just enables us to run a very stable streaming experience for our customers. Now just to quickly talk about what does this really mean for us to run a bigger, stable platform for streaming, and where does Confluent fit in all of it? So we are running at this massive scale. I just spoke about 30 million or 50 million concurrent users, and mind you that the next bigger tournaments on other platforms, they're running at maybe 5 million or 10 million concurrency. So running at this massive scale, we require our system to be resilient and elastic at all times, and which is exactly what Confluent Cloud native service provides us. There's a big difference between a BAU day for us and an event day, right? So there are maybe 100 days of event in any year, BAU, and the event days are maybe 10x or 20x of what we do on a BAU day. That means that before any bigger event like IPL, we spend a considerable amount of time managing and scaling Kafka, and moving to a Confluent managed data streaming platform has just helped us save months of planning and lots of cost. What that really means is that our developers are not up at night fixing Kafka issues, and we have all been there, right? Like just looking and fixing issues at the night. So yeah, it just frees up our developers not spending time on the infrastructure rather than spending time in building the next set of use cases.
That's tough. That's tough.
The main takeaway I want you to go away with today is that previously managing the infra, running the infra was one of the biggest tasks for my infrastructure teams, right? Because these being a P0 service. Now it's just taken away from our hands and freeing our developer bandwidth, developer velocity in building new products for our customers, which is a win-win for us in the GeoCinema engineering team and for our customers, because we are able to bring in new features very quickly to the market.
Confluent helps increase bandwidth for engineering teams to not have to manage Kafka infra sometimes at 2 a.m. Instead, focus on building business products, making beer taste better. Ben and David had definitely drilled that into my mind.
And deliver a great streaming experience to our customers. So now I'll hand it off to Sean, who will tell you about why the data streaming platform can be great for all of you. Thank you so much.
Please welcome Chief Product Officer for Confluent, Sean Klaus.
Oh, shit. It's gonna show up again?
Alrighty. Good morning,
Nope,
everybody,
it's not.
and a big thank you to Mercedes-Benz Research and Development North America.
Please welcome Chief Product Officer for Confluent, Sean Klaus.
Alrighty. Good morning, everybody, and a big thank you to Mercedes-Benz Research and Development North America, to Accenture and Viacom. What a tremendous set of use cases. You know, those are just 3 examples that highlight why the data streaming platform is so crucial.
MuleSoft.
It's the key for those companies to go from data mess to data value and delivering the use cases of today and of tomorrow. So we saw some examples. We saw an automotive company delivering personalized driving experiences. We saw a services company delivering global innovation at massive scale, and we saw a media company delivering sports streaming in a global sense. But those exact same kind of patterns exist in every industry everywhere. I mean, consider predictive maintenance in manufacturing or digital banking in financial services, remote patient monitoring in healthcare, or personalized shopping experiences in retail. They just go on and on. And we saw a media company delivering sports streaming in a global sense.
So these are
But those exact same kind of patterns exist in every industry everywhere. I mean, consider predictive maintenance in manufacturing or digital banking in financial services, remote patient monitoring in healthcare, or personalized shopping experiences in retail. They just go on and on. And yes, the data streaming platform is ultimately the key to solving a limitless number of use cases across every industry, including you and your industry. Now, our job is to help you unlock that value. And to do that, we have to do 2 things. We have to make data streaming simpler, and we have to make data streaming more powerful. And that's where this notion of a complete data streaming platform comes in. Now, we could talk at you about the different components of the data streaming platform, but today we want to take you through an end-to-end journey across the data streaming platform and show you how it sets the foundation for data agility today and in the future. And to do that, we're going to build a use case, and we're going to build the following use case. And as you're going to see, those are dramatically different in size, scope, and effort. Let's jump in so we can show you. Now, I'd like you all to put yourselves in the shoes of River Retail, a primarily online retailer that's looking for ways to re-engage customers who've shopped, put items in the shopping cart, but then have left without completing the purchase. Now, in this use case, it isn't just going to be a matter of streaming data from A to B. We're going to use the cart looking for ways to re-engage customers who've shopped, put items in the shopping cart, but then have left without completing the purchase.
But imagine someone like Shopify probably uses this as well. Shopify use Confluent. Flash sales. Okay, it's interesting, yeah.
Now, in this use case, it isn't just going to be a matter of streaming data from A to B. We're going to need to connect to relevant data sources. We're going to need to govern the data to make certain that it is safe and reliable. And we're going to need to process
elastic serverless stream processing job, and I didn't have to worry about any of Flink's configuration. Here is very powerful. Remind them, hey, there's free shipping over $50. And we're going to do this in Flink, so let's roll the demo.
It sounds like.
So this Java code that you see is a Flink table API program. And what we're doing here, running an aggregation query. And what this query will do.
This is really successful. And part of our philosophy was try and serve customers.
And so that's what we built with WarpStream. WarpStream has what we like to call a zero-disk architecture. And so you can look at the entire WarpStream stack, and there's in Gold Sky.
Okay. Yeah, I am sort of losing my concentration here. It's already 4:17. Let's see how the stream is doing. Okay, it's about an hour in. Okay, stream is still going pretty good. So I think with this, I kind of do want to look through maybe not the quarterly. Okay, I want to look through the SEC filings and build like a little skeleton of a model right now. Yeah. So I kind of understand how it works, right? I understand the use cases. It seems like there's a lot of marketing in this keynote, but I'm starting to get a better idea of what the problem they're trying to solve is. It seems like they want to create a faster, more efficient way of being able to move data around a company. That previously was done through, it seems like, these batch processing. Batch processing type movements where I'd imagine a lot of data was collected in this, we'll call it an internal local database, and then slowly over time, you'll take these big batches of that data and then move that over to a different database. I think maybe the Kafka streaming service is a way of continuously collecting data, and instead of having to have a local database storing that, you can just immediately transfer it over to a data warehouse, Snowflake, or even a database, like a centralized database, something like that. That's my thinking. So you have these constant pipelines that are always communicating with each other. And it seems like it's being adopted by some of these pretty awesome, great companies, right? Accenture, GeoCinemas, which I never heard of, but it seems to be pretty big. I mean, it has 600 million users. It's the most downloaded app in India. in 2023, and Mercedes-Benz. Everyone knows about Mercedes-Benz. So with that, I think this is where we can start. OneDrive. I'm going to connect to I don't know if oh shit. Okay, so let me create a new. Okay, so I'm having trouble with this. Oh, no, not stop streaming. Okay, wait. Delete this. Okay, nice. My live stream, I can move this here. I can take a look at the chat. Okay. But this looks good. Though it is kind of slow, that's okay. Let's take a look at SEC Edgar. Confluent. I actually might be able to pull up on Excel. Cloud software. Okay, so I think this is what I have from my other cloud Excel spreadsheet. Manage Kafka clusters I spin up in Confluent and take care of something called the core engine selling point. Okay. So, subscription and services. Man, oh god, this is not good. So net retention. Yeah, net. Dollar-based net retention. Starting with the ARR from the cohort of all customers 12 months prior to such period. Okay, so excludes AR from new customers in the current period. Okay, so is there value in shifting over to a consumption-based model? Yeah, I'm not entirely sure because maybe their previous model of annual recurring revenue, I mean, is this even a good metric to track, right? Because if the revenue is consumption-based, then it is probably sticky. Sorry, not sticky. It's probably volatile, right? And I guess as an investor, it's not great to see pretty bumpy revenues that could rise or grow. Right. And they're just basically annualizing the consumption over the course of the year. So that's not even recurring revenue, right? It's really non-recurring revenue. NRR. Yeah. Okay, so net retention rate. Period end. Okay, so okay, damn. So ARR of all customers prior 12 months prior to the period end. Then calculate ARR from the same cohort, but in the period end. Factoring in subscriptions that expand, renew, or shrink. I guess contract would be the also add in assumption from Confluent Cloud. Annualize the past 3 months consumption. So then we divide old resulting NR. Okay. So divide the new by old to get the resulting net retention rates. All right, that's good to know. research and development, sales and marketing, restructuring. Okay, so imagine these guys are probably cash flow positive. Ooh. This is really annoying. Okay, never mind. They are cash flow negative. Business combinations, net of cash. Okay. Proceeds from issuance of common stock under employee stock purchase plan. What's going on? What is going on? Okay. This is very annoying. Yeah. Let's... Ooh, okay. I'll be back in a sec. I gotta use the bathroom. Alright. Is this better? Kinda, sorta. Okay. TM Bay. Oh god. Oh god. Alright, I think I might switch devices real quick. Gonna switch devices real quick. What do I want to wear? I guess I could wear this. It's kind of chilly in my room. Going to delete this. Might open Discord up. Yeesh. Ain't no way. Ain't no way. Wait. Median. Okay. Let me start this video call real quick. Alright, nice. Move to bottom. Alright, here we go. It's cooking now. Ooh, and it's smooth. The latency is still kind of rough on the streaming side, but on my side, it's very clean now. Okay, so let's take a look at subscriptions, services, right? 3 months ended June. Security. Guess this will be Q2 now. So includes June. Geographic. And internationally. Oops. Right. Okay. 0, 7, 5, 7, 5. Okay, 9, 2, 5. Okay. So, let's take a look, right? Year over year, it seems to be %. Oh, right. Okay, so let's do currency, right? Yeah, let's make this into currency. 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 Okay, nice. Okay, so this is in thousands, I believe, right? It's at 250 million. Year over year. Alright, so this is Confluent platform license. Post contracts, customer support, maintenance, and upgrades. Okay. 26958. So slowly it's decreasing sequentially. So 25 for 4. $83.81. $83,578. 7,360. Okay, so cloud seems to be the big business here, one that's really scaling. Sequentially, okay. Services 12,797 and $10.4. So growth So this annualized should be around 8. I guess this annualized is about 8 billion. Sorry, 1 billion. And then I guess the multiple here today is almost a 9-10x revenue multiple, right? Which is already above the median, I'd say. What about this? 7.5. So slightly above the median of oops. Okay, about 9.1. Wait, really? Market cap is 0.3 confluent. Total outstanding. Okay, so definitely doing something wrong here. Calculate market cap. I am actually very curious now. How does, let's see. Default shares. Let's see. Point 7. 0.6. Okay. I don't know if that's still 100% right, but we're getting closer. Alright. I think maybe if I were to compare this to like a MongoDB, let's take a look. I'm actually very curious. Cloudflare. Month revenues. Sarah, Datadog, Snowflake. Okay, 16x. I actually don't know what OneStream does. To MongoDB. So same what? So MongoDB is trading around similar to what it seems like Confluent's trading at. Okay, so Elastic is actually somewhat even less. $70. Dates. Okay, so it seems like at one point it was trading very high. Let's take a look at Confluent. And alright, sits somewhere in between. Okay, cash flows. Yeah, I guess if we measure it at a cash flow. Okay, yeah, cash flow wise, this company is just not doing that great, right? Yeah. Okay, 50x free cash flow. Amplitude. It's Couchbase, but I don't think a lot of people use Couchbase. Just add it here. Fastly cloud platform for content delivery. Sprinkler. Hey.
Just need like a stack of books.
Alright. Specializes in digital knowledge management. SEO, PPC, content marketing, optimization. Okay. So not super similar. UiPath. I would add that on here just because I think it's one of the end markets. Sort of this idea of agents or agentic product. Marketing campaigns, Asana. Making solutions. Sentinel-1. Cloud-based security. Maybe I can add HashiCorp on here as well. I think this is, without even looking at it, I think related to the idea of it provides stuff of like real estate management, real estate listing, construction management. Never mind. Shoot, software intelligence for monitoring performance and security, which I think probably benefits from GitLab. Actually, yes, it was. Performance management, data management, backup solutions. So Rubric. HubSpot, Snowflake, Shopify, IoT solutions, show operations, content delivery, internet routing. Okay. Datadog. Yeah, I'll add Datadog here. Yeah, that's kind of crazy. Trace is 15. Sense. Trace, UiPath. So now a lot of these are Rule of 40 type software companies. And what is this? Rubric, Dynatrace. And it is profitable from a free cash flow perspective. Yeah, this is tough. This is tough. I think when we look at these metrics, it's not very interesting. But I think from a technological point of view, I mean, Confluent software does seem very interesting. And if we can get the multiples up, Let's see. So right now, free cash flow multiple is pretty it is pretty crazy. 125. Right, to double check. Confluent. Right, so right now it's generating negative free cash flow. Revenue multiples, 12 month. So implying 29% growth top. Oh god. Ugh. 49%. Year on year. %, year on year. That's a rough one. That's a rough one right there. Okay, trying to see. Wow. Okay, Netflix is up 13%. Okay. I guess I could really take a hard look at a lot of these companies, right? So Elastic, Confluent. Maybe if you look at the companies historically, how they've been trading. Okay. September 30th. Let's go back to, is this June? June 30th. This is also June 30th. March 31st. Okay. So about 6 months from September, I say. Yeah. Okay. To 740. Okay, so I guess the market is forecasting consensus. It seems like
that revenues are actually going to grow at a faster clip right now. About a like 4 to 5% faster clip, 29% year-over-year growth. It seems like in terms of revenue for the next 12 months. So trailing 12 months revenue, we get right 902. I don't know where. Yeah, I don't know where this number's coming from. About 15. Yeah, I'm about $13 million short. Not entirely sure what's going on here. Just like this. T11. So it is 0Q. FQ0? CF. Fiscal 0. Wait a minute. Okay, FQ minus 1. Okay, that's right. Minus 2, right? Okay, so this is where that number is different. $201.81. one. I guess maybe this. Was reported differently. That's my guess. Yeah, okay. Oh, I see. I see. Yeah, I'm missing a Q4. Okay. So this is, I didn't get this right. Got it. I'm missing a Q4 here, which should have added here somewhere, but makes more sense. Okay. Subscriptions and licenses. Okay, platform license. 19. Confluent Cloud 106 2 73 638. Two, okay, and then 10, 3, 5. Wow. Wow. All right. Yeah, I feel like it is sort of misleading the way they mention subscription. Confluent Cloud. Alright, we do see I don't know what happened. Sequentially. Guess they must have signed a big deal in the licensing part. $840. Recognized. Next 12 months. 60%. Currency, got it. What is this? September 30th. 883. So remaining performance obligation. Be the 10K. Why do these keep popping up? Subscriptions. %. So it's about, okay, the same. Gross profit. So cost of revenue. I wonder if they break it down by. Yeah, I don't think they do break it down by business line. Okay. Cost of revenue, subscription services, total. Ended June 44 188 1372. Okay. So 52 863 1218. I'm actually going to add this over here. Oh, shit. Percent margin. Wow, so I guess margin-wise it does improve over time. Okay, so operating expense. Research. Expense. Sales. Marketing. R&D. M. G&A, structuring, so 85 677 7770 363. right? And then 06, 060, 132, 865, 39, 49. Two 354 250 733. It'll be nice to apply this across the board, right? I don't know how to do that, but operating income. Oh, right. Okay. Operating income, total expense, so slowly getting through to positive operating income, right? So operating loss, percent margin, okay, then other income net, imagine it's probably related to their financial instruments. So EBITs, profit, tax, net income. Profit before tax. 7 0 6 7. Vision frame text. Okay, nice. Alright, 4 3 5 1 8 5 5 6 5 4 9. Okay. Real cost of revenue. Gross profit. Oh shoot. Okay. Might as well, right? Okay, so this was 2023. 2022. Oops. Four 104. Shoot. One 1 4 3 1 2 3 0 4 1. September 2022. I think interest rates rose by I guess not by much. In 2022, right? I think probably around 2-3% back then. But back in August, it was high of 5.25 to 5.5 target federal funds rate. Okay. So I do think most of the other income is probably interest income. Okay. Negative 116.029. Subscription. Go. Here we go. United States. 95126 56606. One. Year over year. Yes. Oops. I'm getting some reference errors. Okay. I see. That is okay. Let's go. Getting a lot of divs. It's not great, but we'll fix it. Okay. $95. Okay, so 56. 151732. So license 7120. Confluent platform PCS 64688 then 56922. And 51732. Okay, nice. So we could just add, guess keep going. I don't know if I do want to. Data, we'll group this. Group, right. Group, and then bang bang. Let's group this. Okay, bing bang boom. Nice. All right. So I'm very curious. Yeah, maybe I'll do this. Do you like the blue text for hard-coded? Right. Maybe I'll do that for now. Okay. Okay, this isn't the full picture yet, I don't think. Right. Okay, so let's keep going. Q4 data I think will be pretty critical in 2023. $60 billion quarterly results. Okay, wait. Review all news. Fourth quarter. Oh my god. Okay. Yeah, I saw something that was interesting. I forgot where it was. I guess they do not have a so confluent cloud. So this, right, okay. Annual report. This aggregation of revenue. I guess I can just maybe add this together. So instead of 464 857. I guess that makes sense. Okay, 362 132. Then I guess this is probably the best way to do it. 2 4 6 7 6.你说要开始吃呢？你说要吃吗？没事没事，我可能10分钟。Okay. Dinner is going to be served soon. Right. Dinner is going to be served. Wait a minute. 20, 21. Okay. 4, 1, 1, 8. I'm not too sure where I got these numbers from. Interesting. Oh, so the yearly numbers. Yeah, no. Do not want that. Okay. 2022. 2, 2, 3, 1, 2. I see the problem here. I see the problem. Okay, so this should be 585944, right? And then 2023. So this should be 312 095 77 952. Confluent license. Oh. 84025. Yeah, so that happens. Yeah, almost done. Okay, this is weird. Yeah. Yes. 6 5 4 7 3 1 8 3 2 7. Confluent Cloud 94179 211 1 7. 7, 3, 4, 8. I can see why. Yeah, the growth rates here are very impressive. Okay. 3, 4, 7, 0, 9. Services, yearly services, so 4, 7, 8, 4, 0, 5, 0, 9, 3, 5, and then 4, 0, 7, 6, 5. Okay. Got it. Okay, so I guess these are the numbers. I mean, these are the growth rates. Very, very impressive. I want to say when did Confluent go public? 2021, right? Okay, exactly 2021. It's probably when they hit a milestone. Okay, so with that, I am going to probably end the stream here and then catch you guys next one. Thanks for tuning in. I think Confluent's an interesting company. We'll keep going. Keep streaming, keep learning more, and then also need to finish some of this VFC stuff too. So thanks for tuning in, and I'll catch you guys next one. Peace. Yeah.